how important it is to have a IoT-fied device.
There are a lot of protocols which through which the entire industry is built upon. And then also the wide range of teams that I get to interact with. I'm not sure if in MNC you have a firmware guy interacting with a one who is in a design space. I mean, 3D design or something, product design.
How did you go about in making a firmware for a device from scratch? Hi guys, this is Vaibhav. I'm one of the co-founders at Kazam and welcome to our podcast. Today we have Mr. Rohith Sam, and Rohith Sam handles the firmware division at Kazam, and basically everything that happens inside a charging station and all the intelligence that goes inside the charging station. So welcome Rohith.
Yeah, hi.
If you can if you can introduce yourself to the audience.
Yeah, so this is Rohit here. So I finished my graduation in electronics and communications in 2014 from an IIT university, and then later, I mean, fell in love with hardware, and then I started, exploring more different kinds of hardware, and then the one that gives me kick is putting the code in the hardware, and then you can instantly see that turn out something.
Yeah.
So yeah, that's about myself. So I basically take care of firmware here at Kazam. So again, the piece of code that goes into every charging station.
All right, great. So did you what was your work journey after college? Where did you work before Kazam? And yeah.
Uh, uh, we had something like compulsory internship sort of thing in our college. So in this we were sort of an experimental batch in our college, wherein we got an opportunity to choose to do internship either in 6th or 7th sem. Seventh and 8th sem. So I choose to do in 7th sem, and then actually I've got an opportunity to do internship at a firm in Delhi. So it's called Ahoy Systems. So there we were doing everything. So basically, right from soldering stuff to counting inventory, counting how many number of resistors are there. So counting LEDs could be out of a packet. So there are a lot of stuff, and eventually I was also given some firmware tasks to writing code for some display drivers, and that is where actually I started into firmware development. And then I've gone back to my college in 8th sem, and from there again I went back to Ahoy after 8th sem.
So what did Ahoy do exactly? What was their offering in terms of business? And
Ahoy was sort of a consultancy services in IoT space, you could say. So they at that point they got concentrated into LoRaWAN. It's a different technology that came up, and then so that is what they were concentrating back then. So and it's sort of a consulting firm in IoT space.
so I guess you joined Kazam after that.
Later I left Ahoy to start my own startup with two other friends of mine. So again I felt this LoRaWAN is a great thing, and then and then it was picking up. There are a lot of companies coming in, and then we felt there is a real demand where we can use this technology. I'm not sure if that was the right approach. So we felt LoRaWAN was something that could be. Coincidentally, another friend of mine also had the same experience with LoRaWAN. So we thought, why can't we use this to build something in retail sector? So we had then we started working on an idea wherein collecting all the resources in retail space. Say for example, you have a Decathlon store, so they would be having some 10 stores across the city. So what if I could go to the city in charge of Decathlon and could show him, so this is how many units your X store in Bangalore has consumed, and this is how many units Y store in Bangalore has consumed, and you can compare the sales data also.
Alright.
So you can say even though there are less sales there, it's sort of a gamification. And then we also met a lot of clients in this space. There's a real requirement wherein they wanted to manage all their energy utilization, right? Because there are a lot of these are very big stores, and
You were thinking from a energy monitoring or energy management solution for from a remote internet connected way and not just yeah.
so energy and resource. So energy is in general energy, and then we wanted to include water metering thing and other stuff, and then control their signboard, billboard.
Right. Great. And then what made you join Kazam?
And then and that was that at a point we I think this COVID struck badly, and then was sort of working on myself and thinking what to do, and then at Ragno itself, which was my previous startup, so we started making courses. So we thought we could sell courses. So since COVID, retail was the hardest hit, and then we started making courses. So we then we were randomly putting posts on Facebook and getting people. So finally we had around we ran around 3 courses, which had four to five people in each of the course. So after that, and that suddenly ended, we thought, I think this is not a sustainable thing. We cannot take this longer. So then I started looking on LinkedIn, and then you were the one who I think interacted with in Kazam the first. And then it was very initial stage, and wherein Kazam was also developing their own first product. So that is when I think I joined, and then and energy sector was, I know it is booming the way we are going, and
Yeah. So when we I do remember, obviously you were one of the first hires from with Kazam, and when we moved to Bangalore, and to the audience, he when we moved to Bangalore, he just came and he started working on the, at that time we were building a charging station, so he kind of started just exploring that. When we talk about let us talk about a little about the IoTification of things. So IoT, I mean, the word has been around from past, a lot of years, and where do you see this? Like, one is that we are into, Kazam is into EV charging business, and you are working into EV charging station. So how important it is to have a IoTified device, not just charging device, but where in case I have a fridge or I have a microwave. Now the thing is that everything is now becoming IoTified. So what is your take on that? Like, is it how this IoTification of the things that is around us is happening? So what is your take on that?
right. It's sort of a boon and a ban sort of thing. Specifically with EV industry, I feel this IoT is where that's a boon. And if you think on other things like having your heaters connected to internet, I mean it's fun, but it also sounds scary. I mean there are a lot of articles wherein there's certain company which sold some heaters, and then imagine what could happen if all these are hacked, and then all of a sudden you can turn on heaters across, say there are 10,000 heaters sold from that company, and you could turn all those heaters on, hacking them and turning them on. So you could in fact kill kill the entire grid. So certain things, it sounds good to have, make them IoTized, but again, I feel we have to weigh down the pros and cons, and then should.
So when we say IoTification of something, what exactly when you say, it's just that, it's connected to internet, that's it, right? It can be through Wi-Fi, SIM card, Bluetooth, but this is something you mentioned like LoRaWAN. That's how things become IoTified. And what in your experiences are the first devices around human beings that were IoTified and are gonna be IoTified? So like for example, if I think IoT devices. So I honestly, the POS machines I would say were probably the first device I would say which were connected to internet, and apart from the computers and phones that we have. So that was one thing that I would say, okay, these are the, but which are the most devices being used? Because I also worked in a smart home automation industry. So we were selling smart bulbs, smart cameras, all of them connected to internet, and obviously can be operated remotely. So one point is that in this industry of IoTification, which devices are the first ones from a B2C category and a B2B category, the ones which really need to be IoTified is the first. That's one thing. And also, yeah, and the second thing is that if I am near the device, I can operate it by BLE as well. How do we take a decision whether you can just run it through BLE? Do you really need to connect to internet or not?
Right. And that's an interesting thing wherein there are multiple things here. So do you want to use IoT for just extracting data out of it, or is it a control appliance? So there are two things here, and so most of them could have both of this. So like in EV charging stations, we do have both. You want to know the data that is going through the station, and then you also want to control this. So that's sort of an thing wherein you can for the BLE thing. So again, BLE, there's a lot of improvement in the BLE area. So you can think on the granularity of the data. So, but there are a lot of chipsets which now come with both Wi-Fi and BLE.
Okay.
So that has made the industry more better, wherein BLE could also be used for just authenticating if you're actually near the device or not.
Yeah.
So yeah, in terms of which are the very first device that are IoTized. That's historically, I'm not sure which are the first devices that are IoT-fied, but there's very interesting scenario wherein people, the way that we used to get the energy bill, somebody used to come, right, and then he used to take his there's a machine that he comes up with, and then he just enters the serial number of the meter, and then he takes the difference and then prints the bill there and there and give. But now if you go to Delhi, and then there are a lot of places in Delhi wherein they're fitted with the LoRaWAN system, and then it's an automated billing generation for all this energy meters. So this is a very interesting use case wherein you are avoiding large manpower cost. It's just for billing generation. You are sending somebody across the town, across every home, and then so that's a very huge saving in the manpower. So that is one scenario I feel. That grabbed my attention, wherein just by installing a couple of devices, you could save huge manpower.
Definitely, like energy meter. In my past company also, we were working on energy meters, and both 3-phase and single phase, and that was the talk of the time. There was demand. Also in the manual meters, there is a lot of chances of hacking into it manually. People somehow do some hacks, but if it's completely digital meter, it really optimizes things. And now coming to EV charging, the first question comes to mind is that when we also entered into the market, we go to the petrol pump, and then if we are driving an internal combustion vehicle, we just get somebody fills in the petrol. Let's say there is no operator in India. We have operators, but let's say then I can just lift it up and do that and maybe pay somehow. So now coming to charging stations. So why is there a need to have it IoTified? Why do you feel that? Like, why? What's the difference between a dumb charging station and a smart internet connected charging station? And why do we need to go for it? Like, I can just have a normal charging station, like, with just
Right. So the reason is the usually you have petrol pumps and IC engines the wait time at the petrol pump is very less. Just within fraction of seconds you have your petrol fill and then you move off from that location. But in case of EV charging, is not that way. So you have to have, even with the fast charger scenario, you will have to wait at least for half an hour. So you cannot have a man waiting there for half an hour just for your own car, just for a single car, and then but it also has to be monitored. Some way is the charging actually happening or not. So I think and as I mean even this thing is also felt by the it also comes from the pains that the petrol industry is going, the oil and gas industry is taking. There's a lot of manpower even at the petrol pumps. So definitely it'll save huge cost there's a huge operational cost saving there. And yeah, that is the biggest reason.
apart from that, like, in my opinion, is that with increasing energy demands, you will somehow need a way to communicate to the grid.
Right.
Real time, because charging is gonna increase both in domestic segments and in commercial segments, and then once it increases, there is gonna be a lot of pull of energy from the grid, and then somehow in case the grid is maxed out and the already maximum potential is reached in any particular time of day, then the grid would want to shut some charging stations down. So that's what me and at Kazam we discussed that. That's why I believe this new IoTification of not just charging station but all the high energy devices is important, because then grid can control that. Apart from obviously the payment solution, automation, from domestic standpoint, you don't need, why do you need a IoT based charging station from a domestic based standpoint if it's your house? But if it's in my house or my apartment, I may want to automate charging. I may park my car and then go in my home and I sleep. I may not want to come back down to switch off the charging. I may want charging at a specific time from maybe 2 a.m. to 6 a.m. at night, or that time. So these functions, I believe, the utility combined with the comfort is the need why we need a smart internet connected charging stations. Apart from obviously the automation of the operations. So.
And then that's an interesting point that you've raised. And so even in petrol pumps, these are isolated things. There's not a single tank sitting around for an entire city. So, but it's not the same for a grid. So you have grid in Andhra somehow connected to grid in Karnataka. So it's at the end it's a liability, and then somebody has to take care of it. So it's a good thing that you have raised. Again, it's important for us to take care of the grid.
Yeah. Because the way I see it, if everybody's gonna have an electric car, electric bike, then the charging need is the EV need, energy need is gonna be very high.
True.
And the grids have to be prepared, and maybe EV charging solution providers can help via software in the big time. So coming back to the firmware thing that you do, it's like how did you go about in making a firmware for a device from scratch for a charge point, and like what were the obstacles you faced, or like, because this is something being done probably for the first time in an industry. This EV industry itself is new, it's nascent. It's just started a few years back. It was not like that we are making softwares for something which has already been there. So plus the product that we came out with was pretty customized for Indian environment. So how did you go about that?
Right. Again, so once you have the hardware, it's basically the firmware that is written is entirely chip dependent. So first, as we have the hardware team finalizing the design, and then I choose to write the hardware for that particular chip. So if somebody changes the chip tomorrow, I cannot flash the same code in the other chip. So yeah, once the chipset is chosen, then the work begins. And
You say, sorry to interrupt. When you say chipset, I mean, like, is it what you're saying? Is it a design? Are you saying you're the manufacturer? What are you talking about?
it's a microcontroller. It's a silicon basically that sits on a PCB.
Alright.
So that is where, like you have your
I think you'll have to explain PCB to the audience because, yeah, some of them may know, some of them, yeah.
So it's a PCB is something. Maybe we can do an in-depth show.
It's okay. You can explain what you think. I know it's a control board.
Right.
Then what's the difference between a control board and a chip? Like, just a brief.
Right. PCB is a collection of electronic components. It's a printed circuit board. So you have, say you have, just PCB says how those all components should be connected to each other. So that is what PCB basically says. So you have a PCB and then you have a lot of component that goes over the PCB. So yeah, and the talking about chipset, it is like silicon. It's same as you can compare it to i5 processor, the processor that you hear when you look into this laptop market. So it's same like that at much cheaper cost and with much less processing power and with much less memory, of course.
So now the chip is finalized. Now you decide to make a firmware.
Right. So and then obviously and it is also talking to, since it's a connected solution, so we would also need our cloud team. I mean, how the important thing becomes in how do we share the data from the device to the cloud. So it's all on formulating the protocol. So that is again, it's a team effort. Once that is done, and then you have proper requirements and putting your safety things into concern. You just have to jot it down, all the things.
So, all right. So one is that at what point is the work of hardware stops and firmware begins, and then at what point the work of firmware stops and the cloud begins? So, like, in what my understanding is that you work as a connection between the hardware and the cloud. The functioning of the device, and then obviously the cloud takes over for the communication protocol. So, if you can explain that, like, where does the firmware start and where does the firmware ends?
So, and hardware design is, I would say, it's a difficult process, wherein it difficult in the sense of the time it takes. You don't have all the resources here. So if you just for a single iteration, it near around takes about 45 days. So you have a PCB that is printed, 45 days effort has gone into it, and then the developer, hardware designer realizes there is a small 50 paisa resistor that is missing on it, and your firmware will not be running on it just because there is a small 50 paisa resistor that was missing in the design itself.
Okay.
So it's sort of a continuous development even with the hardware team. So the firmware team and the hardware team should, work continuously. There could be so if hardware doesn't work, the code will not work on it. So I think once that proper iteration has been done and proper testing has been done. So then there are individual test codes that go into the board. Say for example, a particular board is assembled and it has 10 particular components. So individual component level testing is done, and once the hardware team says everything is all right from their end, so it's handed over to me, and then I do as a component level testing with the piece by piece firmware, and then I say this is okay, so I'm good to write firmware. So and it's the same with the cloud team. So it's a continuous development both ends. So you have so once your protocol is decided, written in paper, and then we both, if the cloud guy and the firmware guy, we agree upon that protocol. So it should be done, but yeah, I think the more effort goes into dealing with the hardware guy than the cloud.
Yeah, and maybe if from cloud side, I think there is standard protocols, right? There would be either MQTT or OCPP. I mean, and then you just go along with that. And which language do you guys use to write the firmware?
So I use C++.
Okay, and is that the industry standard?
Not it's not like a standard. So there are C++ offers better way to reach in depth into the hardware, but there are Python. There are Python wrappers over it. You could also write code in Python, and you could also code in JavaScript. But it's more of it's not just it's not, in fact, this industry in firmware, it's not, you cannot choose actually. So it's sort of once the silicon manufacturer decides, makes the
So the chip comes, does that mandates like this chip will have firmware in this particular language or platform?
So mostly all the things work on C++. So, but there are communities built for certain chipsets who had made their own Python wrappers over C++, and then that allows people to write code in Python as well. So, if there is a community, or if the manufacturers themselves took this interest to develop this layer of Python code, and then so that Python wrapper over it, so then we can do it. Otherwise, it's not possible. So C++ is the go-to language for C, and C++ is the go-to language for
there has been a lot of talk around safety for EV charging, and you have been closely involved with the firmware development, as well as Kazam software integrates with other charging manufacturers which have their own firmware and communicating via OCPP protocol. So when you made the firmware, or as any firmware developer working for EV charging industry, what all parameters from a safety standpoint they should be keeping in mind?
Right. So there are certain things here wherein there's a ready-made standard that government has already published out. So the best thing for one who is starting out could be to directly look into those standards and follow these standards. So most of them, the standards that are mentioned are comes with the hardware design itself. So you have to design your hardware in such a way so that the standards are met. And so the guidelines specifies most of the standards that has to be followed for any EV charger design.
Okay, and all right. And what do you feel is like you haven't now seen too many OEMs and charging stations, and what do you think is the importance of a charging station while using an EV or charging an EV, like I can charge it directly from my home socket. So what do you suggest there? Like, firstly, should people be charging via home socket, or should they be going via charging station? If yes, then why?
Right. So we have recently seen a lot of incidents wherein there are a lot of fire accidents that has happened. Just a lot of people were using their home sockets to charge their scooters or bikes, and then it has raised all of a sudden, specifically in summer, wherein cases were increased dramatically. So. Home socket is something that's happening in an uncontrolled environment. So and then there's nobody to monitor. So the industry itself is so new that people are these are I mean the lot of scooters are picking OEMs are coming up from every nook and corner.
Yeah.
So it's sort of a and there's a DIY world in itself where people are making their own electric scooters and bringing them on road. Just the market time for them has also reduced because of a lot of policies by the government. So I think and there are obviously safety concerns there, and there's not an accelerated testing that has gone into all these things. So if the product has come within 1 year, so there's need for an accelerated testing, right? So but that is missing. So having a safe EV charger, having an EV charger is very safe, which meets all the guidelines and then stops if you're charging in hazardous situation.
And like yeah, I mean, same thing that I've been discussing on this podcast with previously as well, that I mean, even though there is a connector from the socket to the vehicle, but still you're charging a pretty heavy battery, and you want to minimize the risk to your own house and then the transformer. So you need those protections, the RCD fault, the earth fault, the circuit breaker, the glass fuse, and all those things, just to make sure that any protection against overcurrent, over voltage, or leakage current, or earthing fault, or so those things I believe are definitely where a charging station definitely adds value to the EV charging. And what do you think, career opportunities in EV industry, for the electronics and firmware people? Does it brings a lot of opportunities with itself? And if yes, then how can the aspiring people join this revolution?
Right. Electronics industry is itself, it's booming. I mean, even the IC engines require electronics to go inside it. So and then obviously EVs also would be requiring electronics that goes into electric vehicles. And then as I personally feel there's a lot of boom with the EV industry, and it is going to be there. So and then also specifically if you talk in software, there are a lot of protocols which through which the entire industry is built upon, like OCPP, and then you have the industry built on this protocol. So you can try implementing. It's an open paper, so you can find it anywhere on the internet. You can try building this system yourself, and then not an advice that I will give. Even in your old company, I as far as I knew, they were moving into energy sector, right?
Yeah.
So where they were building their solar power,
Solar rooftops.
something in solar.
Yeah.
So initially, how did that start off, and then why is there sudden jump into solar?
The jump was from solar into home automation.
Oh.
So they were into solar rooftop installation. I was handling the South India business from sales to installation. That's where I got my insights into EV charging. That if people are using their rooftop to save money. They can use their parking spot to make money. That's when I got the idea that a lot of people will have charging stations. That's why I got the idea that there will be a needed software service to manage these assets, and so that grid can handle that. And that's when I got in touch with Akshay. He kind of immediately related to the idea, and we started this. Yeah, but then from solar they shifted to home automation, and that's where I got my experience for the product side and IoT products, and that's how whole thing came together. I could understand how IoT based products are created and what goes into IoT products. At least till a product creation understanding or requirement understanding, how a product requirement is created, how customers need is understood, and then how we communicate with the tech team. And then as well, the beautiful thing about creating a tech product or a IoT product is that you're not just interacting with one platform team. There is an app team, there is a web team, and then there is a IoT team, and all three are working together. And in IoT, then there is a separate power electronics team, and then there is a person who is working from a cloud perspective. So all these three working together is something that really helped me in building things at Kazam. Because at Kazam also, I believe we are from product side, I believe that it's not just one platform. Like I have I have let's say a platform for tax saving, or I have a platform for sales, and there is just the product is the web view that you see, and that's it. It's not interacting with some physical device in the world. And so when we talk about IoTification, when you talk about an IoT device or charging station, the beauty part is there is some physical device that is connected to the cloud. Then cloud is connected to a front end, which can be a web view, or it can also be a separate mobile view, which again is a different tech stack. It is either React Native or Flutter. So this whole thing coming together is what I find both challenging and yet beautiful at the same time. So doing this all in-house helped Kazam to kind of scale and then offer the solution that we have built to other people as well. So yeah, that was the beautiful part.
I just had question on solar thing. Say suppose I install a solar rooftop, and then what is it with the excess energy that I generate? So how do I sell it to the government?
So there is a power purchase agreement between the party and the discom. The procedure is it was pretty documentation intensive process. That's why maybe it was not that scalable.
But does that happen? Do people sell to the grid?
Yeah, so how it happens is that, let's say the project starts, you get a feasibility agreement signed that this is feasible, again signed by your AEE or AET of your area, it's assistant engineer or technical engineer. Then you go and install the solar, and then you install a net meter. A net meter is different from your regular meter. It is a two-way meter. It calculates energy both the ways, going in and out of the grid.
Import and export.
Yeah, and how it is done out of your meter, and how it is done is there is an inverter. Inverter is basically which converts your DC power to AC power, and then gives it to meter. And the inverter raises the voltage when it has to give back power to the transformer or the grid. So it increases the voltage if you have excess power, and that's how it works. So the concept of net meter is it counts the power both the ways, and in case you have an excess power, the power goes to the grid, and you will have excess power mostly during the daytime because you're not using it. So power is being not utilized. You're not in a house, you're mostly in office. So the power goes directly to the grid, and it is purchased, last time I checked, at the rate of 2 rupees 99 paisa per unit.
Okay.
So you sell it that. However, if you are using it, let's say you are in the house on Sunday, you're watching TV, you're using AC, then you're using it for yourself. You are not selling it, but then it's your energy, you're using it. So that's how it works.
I have a cousin who is actually working with solar technology, and then it's a very deep research that they're working on, and there are a lot of solar based research that are happening. So do you feel the research that is happening in the academia, is it coming into the production?
In terms of solar panel efficiency, yes. I mean, when and cost efficiency, yes. I mean, in during my work period only, I saw a panel coming from 325-watt panel for the same surface area, which was around one panel, same dimensions, and having 72 cells, and that coming to 360. And now I believe the industry has reached, well, if I'm not wrong, around 400-watt panel. So the same panel, same dimension, is now able to generate 400 watts. So we needed 3 panels for 1 kilowatt.
Mm-hmm.
It was 330 on average at that time, but that is definitely increasing. The quality of cells is increasing.
Okay.
So the quality at which we can convert the sunlight into the energy. So that's increasing, and the cost is reducing. At that time, it was not the panel cover, total cost would cost you around 50,000 for 1 kilowatt solar plant.
Mm-hmm.
So I think that's well come down to, I think, 40 to 35,000. So both things are working. I mean, I think it is going good. I have a trivia for you. Why? What is the for 1 square meter? What is the average power Earth receives from sun? Average power Earth receives from sun during daytime per square meter.
There's something that I have maybe.
And then I have a hint. It's a well-rounded number, yeah.
Is it 3 watts?
No, that's too less, man. How can we do? I'm saying one panel produces 330 watt.
One panel produces 3.
And one panel is what? Like one panel is like 2 meters into 1 meter.
If you talk on 1 square meter, it could be this tile, right? Size of this tile is 1 square.
1 square meter will be 1 meter, a little bigger than this table.
So obviously more than 330. Around 330.
It's 1000. 1000 watt per meter square is the average. So which means now you have a panel, which I just told you is if you assume it to be 1 meter square, I forgot the exact dimension. It's converting into 330 watts. So the conversion efficiency is 30%.
Right.
But what if during the peak hour? What if we can somehow, tap into all of that? So that's the maximum potential. You can't go beyond it, but there is a lot of scope from this 330 watt per panel to increase.
Right.
So that's the thing. Anyways, any crazy memories at Kazam or working how do you find working in a startup? That's the one thing. What's your feeling about it? Because how do you feel? It's different. I'm not sure if you have corporate experience, but how do you feel our startups are different from corporates? I guess there will be a lot of friends of yours working in big companies, corporates, like Bosch and other companies. So what do you feel is the difference?
Yeah. So in specifically in hardware and firmware domain, then I mean being in a startup gives you lets you be agile, so you can make things fast. So but I have people who are in MNCs, and then wherein if they want to get some product moved ahead, just to buy some 50 paisa or 30 paisa resistor, they'll have to put mails all down their list, all up their hierarchy. So that is where product development in a startup is much faster, and then your learning curve is much better because things are happening at much better pace. Uh, yeah. So and then, but you also have to be multi-talented. You eventually become multi-talented, so you will not be just doing firmware thing. So you'll also need to understand you also need to write down some scripts in Python or do some cloud work.
So,
that
but
you can-
isn't it stressful working in startup? Or
for me personally, I feel this is the environment I personally like. So, but I think going back to MNC will be stressful for me.
yeah, one thing with startups, I also when shifted from Pepsi to a startup, the hierarchy is not there, and that's the best part. You can talk to anybody, you can talk to the CEO, and that hierarchy is not there. The freedom you get, I mean, nobody stops you for anything, man. You can just, I want to work for this, I want to work for this. Okay, good, come and work. And the informality, the flat structure, and the learning, obviously. I mean, because you're doing everything from scratch. So I mean, if I didn't work for a startup, I don't know whether I will have a startup of my own, because working for a startup only gave me that much insight that I could, I could discuss with the team about the idea.
And also the wide range of teams that I get to interact with. I'm not sure if in MNC you have a firmware guy interacting with a one who is in a design space. I mean, a 3D design or something, product design. So, or somebody who is in firmware talking to a sales guy or the marketing people. So, there's a mixture that you have, and you have you can interact with everybody. That's another thing.
Right. Where do you see this? What's your outlook on EV industry? What do you think is the future? I mean, is it the future? And yeah, what's your opinion on that?
Uh, uh, I would say it's picking up very quickly, and I could think of more fancy things coming into EV industry, just like that Tesla video that we have seen, where the gun comes automatically and goes into the Tesla.
lot of reels floating around.
Yeah. And then
There's a lot of videos of drones coming in, flying, charging the batteries. Yeah, definitely. I mean, we obviously, Kazam philosophy is that EV is the next big thing, and so any hobbies you pursue, and does working at Kazam gives you that time to pursue your hobbies.
yeah, I actually ran a YouTube channel. I mean, I have around 200 subscribers. So I want to.
What's the channel name?
It's called Beyond Breadboard.
Beyond Breadboard. So guys, please subscribe to Beyond Breadboard. Here is the link. All right.
Yeah. So I basically want to make electronics much available to a lot of other people. Yeah.
Yeah, that's great, man. That's great. Cool. Thanks, Rohith, for taking time for the podcast, and I hope the audience would have enjoyed this particular session and knowing your journey, at Kazam and before Kazam, and just keep doing the great work that you're doing. And yeah, that's it. So thank you guys. Do subscribe to the channel in case you like the video. We regularly come and discuss about EVs and electric charging stations and basically the startup ecosystem. So that's it. Thank you, and meet you the next time.